Alright, let's start with the problem for the night. So we'll be doing 2.6, which is using Gaussian elimination, find all solutions of the inhomogeneous equation system Ax equal to b, where A and B are these. Right, so as usual, we will write this as an augmented matrix first to simplify representation. 1 0 1 0 0 0 0 1 0 1 1 0 0 0 1, and this is simply 2 minus 1 1. So in Gaussian elimination, you ideally want to get this into what's called the reduced row echelon form, where each row has a leading pivot which is 1, and any subsequent rows are not allowed to have a pivot ahead of the previous row or at the same level, and in the rows where there is a pivot, the other element should be 0. So those are basically the rules, fairly simple. Let's perform a few row operations. So let's go R3 minus R1, and this should get us, so this will keep the first row unchanged and the second one as usual. It's an obvious expectation, but then this would be 0 0 0 0 minus 1 1 2 minus 1 minus 1. Alright, now we can do something like maybe removing this. Is that productive at all? Not so much. So you can see this already has no zeros here, so that's good. Then this has no zeros here, so that's good. We need to get rid of these two, so we'll go R2 goes to R2 plus R3, and R1 goes to R1 plus R3. So that will keep the last row intact, as that's the only one that hasn't changed. And then this should be 0 1 0 0 0 1 and 0 0 0 1 1 0. But then this should be 0 and this should be 1, and minus 1, this will be minus 2, this would be 1. This is almost in RREF, but you need to multiply R3 by minus 1 so that this becomes 1, and then we get something like this: 0 0 0 1 0 0 0 0 0 0 1 0 1 0 0 1 minus 1 1 minus 2 1. Okay, so we have this, and this is quite straightforward. Once it's in this form, we can just put in the values. So since this has 6 variables, we expect this to be x1 x2 so on and so forth until x6 for each column. And so we take the values for each equation, and that becomes something like x2 plus x6 is equal to 1. X4, is it? Yeah, x4 plus x6 becomes minus 2, and x5 minus x6 becomes 1. Since x1 is just not there, we can assume some x1. Let that be lambda, which is some real number that solves it. This is how we parameterize it when they're independent. So here they are independent. And once you have x1, can we relate this to anything else? No. Okay, then let's assume an x2. Let this be lambda 2. So then this will be lambda 1. If we have this, then, well, x6 becomes 1 minus lambda 2 from this equation. And using this, we can find x4. So using this, you can find x4 is minus 2 minus x6. So that is minus 3 plus lambda 2 is equal to x4. And using this further, so we used this earlier, now we can put this here. So x5 is equal to 1 plus x6. So that is x5 is equal to 1 plus x6 is 1 minus lambda 2. is 2 minus lambda 2. So you have x1, x2, x4, x5, x6, x3 is again independent. It's just not there. So you can parameterize it as a different real number because it's independent. Let me move this. So that could be x3 could be some lambda 3. And this is assumed, and this is assumed. So if you look at the solution vector for this, so if you remember, the matrix we were using, which was matrix A, was 3 cross 6. So we expect x to really be just a vector, which is something like 6 cross 1. So that the resulting one is B, which is again a vector, which is 3 cross 1, as this will be the result of the multiplication. So x is going to be a set where x1 is lambda 1, x2 is lambda 2, x3 is lambda 3, x4 is 2 minus lambda 2, x5 is, no, that is x5 actually, sorry, my bad. Let me get rid of this. Oh, finally got the eraser working. Anyways, x4 is minus 3 plus lambda 2. This is 2 minus lambda 2. x5 and x6 is 1 minus lambda 2. This is going to be the entire vector. This is the set where lambda 1, lambda 2, and lambda 3 are all real numbers. This is how we give a solution. This is how we present it. And yeah, that solves the problem. Fairly straightforward, especially towards the last video already. Yeah. Have a good night. See ya.